Hello and welcome to Safety Tavern's video on Hazcom. That stands for Hazardous Communication. And again, this is an OSHA 1926 focus. So let's get into it. This is going to be a long class. So get some popcorn, get a Coke, and let's get through this. Coming right out of the gate, we've got lead. That is the first major hazardous item that we are going to talk about. Now, lead, we've known about the effects of lead in construction for more than 20, 30 years. So I don't really have to focus too much on it. This is an OSHA fact sheet. Lead is an ingredient in thousands of products widely used throughout industry, including lead-based paints, which is for us, it's primarily where we may come into contact with it in construction. Lead soldering, electrical fixtures and conduits, tank linings, plumbing fixtures, and many metal alloys. Although many uses of lead have been banned, lead-based paints continue to be used on bridges, railways, ships, and other steel structures because of its rust and corrosion-inhibiting properties. Also, many homes were painted with lead-containing paints. Significant lead exposures can also occur when paint is removed from surfaces previously covered with lead-based paint. So, feel free to take a picture of this, and there's also a page 2. But back to page 1. The main place that we're going to encounter lead as a construction overall basis is going to be when you are grinding on something and when you are welding or brazing on something. That is where, especially when you have an older structure and especially when you're doing a renovation. Those are the places where in construction you are going to come in contact with it. Lead, if you do come into contact with lead, you need to get the product page of that product and find out how to protect yourself. We'll go over SDSs later, but you need to get the SDS of what was put on there, and that way you know how to protect yourself. This is lead. Next! Non-ionizing radiation is described as a series of energy waves composed of oscillating electric and magnetic fields traveling at the speed of light. Non-ionizing radiation includes the ultraviolet light, visible light, infrared light, microwaves, radio frequency, and extremely low frequency. Lasers commonly operate in the UV, visible, and IR frequencies. Non-ionizing radiation is found in a wide range of occupational settings and can pose a considerable health risk to potentially exposed workers if not properly controlled. So, extremely low frequency radiation is at 60 Hz and is produced by power lines, electric wiring, and electric equipment. Common sources of intense exposure include ELF induction furnaces and high voltage power lines. Radio frequency and microwave radiation. Microwave radiation is absorbed near the skin, while radio frequency radiation may be absorbed throughout the body. At high enough intensities, both will damage tissues through heating. Sources of RF and MW radiation include radio emitters and cell phones. Infrared. The skin and eyes absorb infrared radiation as heat. Workers normally notice excessive exposure through heat sensation and pain. Sources of IR radiation include furnaces, heat lamps, and IR lasers. Visible light. The different visible frequencies of electromagnetic spectrum are seen by our eyes as different colors. Good lighting is conductive to increase production and may help prevent incidents related to poor lighting conditions. Excessive visible radiation can damage the eyes and skin. Ultraviolet radiation has a high photon energy range and is particularly hazardous because there are no immediate symptoms of excessive exposure. Sources of UV radiation include the sun, black lights, welding arcs, and UV lasers. Laser hazards. Lasers typically emit optical radiations. This includes UV, visible, and IR, and are primarily an eye and skin hazard. Common lasers include CO2 IR laser, helium, neon, neodymium, YAG, and ruby visible lasers, and the nitrogen UV laser. These are your non-ionizing radiation hazards. Next! Ionizing radiation. The Nuclear Regulatory Commission, NRC, regulates exposure of radioactive materials. This includes some source materials, uranium and thorium, special nuclear material, enriched uranium and plutonium, byproduct material, material made radioactive in a reactor, and residue from the millings of uranium and thorium, accelerator-produced radioactive materials, and discrete sources of radium. OSHA requires employers to protect workers from exposure to ionizing radiation sources that are non-regulated by the NRC or other federal agencies such as X-ray equipment, some accelerators, incidental accelerator-produced radioactive materials, ion implanters, and some naturally occurring radioactive materials norms. States also regulate occupational exposure to ionizing radiation. NRC agreement states regulate occupational exposure to radioactive materials within their borders. These states may also regulate occupational exposure to radiation sources that NRC does not, including radiation-producing machines, i.e. X-ray machines, particle accelerators, and norm. OSHA state plans have OSHA approved standards and enforcement programs that are at least as effective as federal OSHA's. The state plans may have more stringent requirements for occupational exposure to ionizing radiation when compared to federal requirements. Overall, meaning your state can be more strict. It can't be less strict, but it can be more strict than the federal government. Now, the big question here is, why is Safety Tavern talking about radiation? This needs to get out of here, right? That's what most superintendents on job sites would say whenever I tell them that we got to do this training. Well, but you got a problem. You see, do you have concrete on your job site? What about welded structure? Do you have any welded structure? What about welded pipe? See, when you have any of these items here, you potentially have radiation. And I know that sounds weird, but you see what happens is this is non-destructive testing. And what they're going to do is they're going to shoot some form, something, some way, somehow, some kind of a signal into the ground. That signal comes back and it gets measured in one of these machines or something similar to this. Well, that's not even the radioactive part. For most of these machines, that's not the radioactive part. What'll happen is that tech will take his machine and he'll go into this truck. If you see these trucks on the job site, this is where most of our radioactive situation is happening. He'll take that digital information, he'll take it to this truck, and he'll produce X-rays. He'll literally produce X-rays of the welds. And what he'll do is he'll immediately give the customer the X-rays, the physical proof of the non-destructive testing that was just performed. There's a lot of companies that'll take the non-destructive testing data and they will take it off site and do the X-rays somewhere else. Some companies, some general contractors want the information immediately, and thus they will have some form of a radiation source inside of their trucks in order to produce that X-ray. This is where we get into job site radiation, and if these trucks are on your job site, just stay away from them. I'm not saying every one of these trucks has radiation, has the radiation cells inside of them, but some of them do. Stay away from these trucks. That is ionizing radiation, and as the barber said, next. And next we have asbestos. Both ATSDR and EPA consider inhalation to be the main route of human exposure to asbestos mineral fibers, and also the route with the most severe consequences to adverse health. Ingestion occurs mainly through the swallowing of material removed from the respiratory tract in the normal process of clearing one's throat. To a lesser degree, ingestion occurs through drinking water contaminated with asbestos or eating, drinking, or smoking in asbestos-contaminated work environments. Exposure to the skin does not result in the absorption of asbestos. Asbestos is not metabolized, aka broken down, into other chemicals inside most organisms. Fibers that are not cleared from the lungs lead to gradual accumulation and persistence over time. Persistence determines cumulative exposure and toxicity of fibers. Amphibola fibers appear to be retained in the lungs for longer periods of time through crystallized fibers. Asbestos is not metabolized or broken down into other chemicals inside most organisms. Again, workers who are exposed to fibers have an increase in mortality from non-cancer respiratory diseases, including fibrosis, which is the thickening and scarring of the lungs, or asbestosis, and deficit in pulmonary function. Asbestos workers have increased chances of developing two principal types of cancer: cancer of the lung tissue itself and the almost always fatal mesothelioma, a cancer of the thin membrane that surrounds the lungs and other internal organs. Workers can also develop cancer in other locations, for example, the stomach, intestines, esophagus, pancreas, ovaries, and kidneys, although this is less common. Exposure to asbestos via drinking water may result in cancer of the esophagus, stomach, and intestines, but it is difficult to determine whether this is caused by asbestos or something else. For this class, stay away from asbestos. If you see warning signs, warning tags, anything posted up about asbestos, stay away. This is not an asbestos training class, thus I'm training you to stay away from asbestos. Here is the OSHA asbestos fact sheet. Feel free to take a picture right here. And of course you have page 2. Feel free to take a picture right here. For this class, understand that when asbestos is present, when there is a known source of asbestos on a job site, that area immediately becomes a no-go area, and the GC must post this job site hazard to warn everybody away from the area. You, under this training, anyone that's using this training, you are not allowed to go into an asbestos area. Stay out. If you suspect that there's asbestos in an area, you need to pull out of the area, get out of there, and immediately notify your supervisor, and do not go back into there until you have been told by a competent person within your company that's on your job site that's responsible for you that there is no asbestos, or that the asbestos has been clear. Also, whenever they tell you that there's no asbestos, you have the right to see the asbestos clearing letter. There will be a letter of certification stating that the area is free of asbestos from a company that specializes in cleaning up asbestos. They will write a letter of certification, and you have the right to see it before you go in the area. That is asbestos. If you have any questions, again, talk to the competent person for your company. And as the doctor says, next! And next we have hexavalent chromium, also known as chromium-6. Hexavalent chromium is one of the valent states of the element chromium. It is usually produced by an industrial process. Hexavalent chromium is known to cause cancer. In addition, it targets the respiratory system, kidneys, liver, skin, and eyes. Chromium metal is added to alloy steel to increase hardenability and corrosion resistance. A major source of worker exposure to chromium occurs during hot work such as welding on stainless steel and other alloys containing chromium metal. Hexavalent chromium compounds may be used as pigments in dyes, paints, inks, and plastics. It also may be used as an anti-corrosive agent added to paints, primers, and other surface coatings. Hexavalent chromium compound chromic acid is used to electroplate chromium onto metal parts to provide a decorative or protective coating. So who is exposed to hexavalent chromium? Pretty much, why are we talking about it? Many workers in a variety of occupations are potentially exposed to hexavalent chromium in the United States. Workplace exposures occur mainly in the following areas: welding and other types of hot work on stainless steel and other metals that contain chromium, use of pigments, spray paints, and coating, operating chrome plating baths. For this specific training, it is mainly spray paints. I've seen it many a times where somebody will whip out a can of metallic-based spray paint, and they haven't even really looked at are we actually exposing ourselves? That is why we are having this class. That way you understand it's not just spray paint. This is where we're stepping up into a different world where it may have something like hexavalent chromium. And as you can see here, they throw in the word hot work on stainless steel, but I'm going to throw in a little bit more of a hot work thing that we don't often think about, and that is grinding. Yes, when you are grinding, you could be throwing hexavalent chromium up into the air. So if there's a chance that it's got hexavalent chromium, you need to upgrade your protective measures to suit the situation. Again, talk to the competent person on your job site for hazardous materials for your company if you have any questions. And that is all we got for hexavalent chromium. As the butcher said, next. All right, next on the chopping block, we have methylene. Google, how do you pronounce this?
Methylene dianiline.
Well, I'm not going to keep saying that, so we're going to call it construction meth. So, exposure to construction meth occurs mainly in the workplace. Liver damage and skin irritation may occur from exposure to high levels of construction meth. This chemical has been found in none of the 1,445 National Priority List sites identified by the EPA. Construction meth is an industrial chemical that is not known to occur naturally. It is also commonly known as MDA. It's known as MDA. It occurs as a colorless to pale yellow solid and has a faint odor. Construction meth is used mainly for making polyurethane foams, which have a variety of uses such as insulating materials in mailing containers. And that is why we're having this training. It is also used for making coating materials, glue, spandex fibers, dyes, and rubber. How might I be exposed to construction meth? Working in an industry that makes or uses construction meth, touching consumer goods such as polyurethane foams that contain it, living near a hazardous waste site, which I hope none of us do, or being treated by a kidney dialysis machine. Tiny amounts are released from the polyurethane parts of the machine when it is sterilized by radiation or heat. Now, for us specifically, can you tell me the package you're about to unpack, before you even open it, what is in there? How many packages do we have on construction job sites? How many times do we open up things like this and we have no clue what the foam is made of? That is why we have this training right here, is so that way everybody who ever watches this video knows, don't eat this stuff. Don't eat it, don't lick it, don't use it as a plate for your food. This foam is not to be mixed with any kind of an edible situation. Don't be playing with it and then smoking. Wash your hands once you're done with this foam. I cannot tell you that all this foam has got construction meth inside of it, but I can tell you there is some foam out there on the job sites that does have this construction meth made into it. And here we have the product pages, pages 1 and 2. This is a generic product page. You can see the hazard summary, the uses, sources and potential exposure, personal exposure, health hazard information, reproductive development effects, cancer risk, physical properties. Feel free to take a picture right here. And page 3 and page 4 are a lot less exciting. Here is a graph for your viewing pleasure, as well as all the references. If there's any questions for any of this, feel free to look at OSHA's website, specifically on
methylene dianiline.
And of course, always talk to the competent person for hazardous chemicals for your job site, for your company. That's all we got for
methylene dianiline.
And as the valet said, next! The very next chemical that you didn't want training on is cadmium. Cadmium is a soft, malleable, bluish-white metal found in zinc ores and to a much lesser extent in the cadmium mineral greenockite. Most of the cadmium produced today is obtained from zinc byproducts and recovered from spent nickel-cadmium batteries. That's right, nickel-cadmium batteries. First discovered in Germany, 1817, cadmium found early use as pigment because of its ability to produce brilliant yellow, orange, and red colors. Cadmium became an important metal in the production of nickel-cadmium, also known as NiCad, rechargeable batteries, and as a sacrificial corrosion protection coating for iron and steel. Common industrial uses for cadmium today are in batteries, alloys, coatings, i.e. electroplating, solar cells, plastic stabilizers, and pigments. Cadmium is also used in nuclear reactors where we shouldn't be anywhere near. While lithium-ion batteries have made significant gains in popularity for lightweight electronic devices, new market opportunities for industrial applications of NiCad batteries will continue to fuel cadmium use. Increased investment in solar power will also drive cadmium use in the future. China, South Korea, and Japan are the leading producers of cadmium in the world, followed by North America. Cadmium and its components are highly toxic, and exposure to this metal is known to cause cancer and target the body's cardiovascular, renal, gastrointestinal, neurological, reproductive, and respiratory systems. I can't think of a single system that wasn't included in there. Cadmium will jack you up. Worker exposure to cadmium can occur in all industry sectors, but mostly in manufacturing and construction. Workers may be exposed during smelting and refining of metals and manufacturing batteries, plastics, coatings, and solar panels. The expanding NiCad battery recycling industry is concerned for cadmium exposure. Electroplating, metal machining, welding, and painting are operations associated with cadmium exposure. Workers involved in landfill ops and recycling of electronic parts or the recycling of plastics may be exposed to cadmium. Compost workers and waste collectors are also potentially exposed to dust which may contain cadmium. The incineration of municipal waste is another source of cadmium exposure. Cadmium is an important metal for many types of businesses and industrial processes. Cadmium is most often used in the manufacturing sector, but worker exposure can also occur in other industry sectors including construction, wholesale trade, and transportation. OSHA provides a publicly available chemical exposure health data, which includes industrial hygiene sample results taken by OSHA field personnel during site visits. These data can provide a snapshot of industry sectors and business subcategories where cadmium air concentrations have been found. While the tables represent only a small fraction of the total number of companies in their respective industries, the results can provide insight into where workplace cadmium exposure is occurring in the United States. Feel free to go look there. If you have any questions on cadmium, talk to the competent person for your job site for hazardous chemicals for your company. And that is what we have for cadmium. And as the old Sawbones used to say, next! Hey, you want to talk about cadmium? Let's talk about some more cadmium. Come on, I got some cadmium to talk about. Well, we're going to talk about cadmium, but it's not exactly cadmium. What we're going to talk about specifically is the safety data sheet for cadmium. We're going to use cadmium as the example. So let's take a look at that. First and foremost, you're going to have the manufacturer's name right up here. Next, you'll have the revision date. Next, the actual product name. You'll have a category number, the CAS number, recommended use, and uses advised against. And right here, you'll see all of the company information. This is in case you got to contact the company. Down here, some emergency telephone numbers. This is the identification section. Next, hazard identification. Look here, right here it says this chemical is considered hazardous. 2012 OSHA Hazcom standard 29 CFR 1910-1200. So this is definitely a hazardous chemical. These are all the category ratings for each one of these specific areas. Page 2, we keep on going with the hazardous. Flammable solid, combustible dust concentrations, fatal if inhaled, harmful if swallowed. Of course, you have your GHS, right? Your pictograms for global harmonization, precautionary statements, responses, if it gets on the skin, if it gets ingested, storage, specific information, hazardous, not otherwise classified, very toxic to aquatic life. Like, this thing is just bad. And in the hazard section is where you'll find this. Next section is composition and ingredients. And as you can tell, this contains 100% of cadmium. Next section, first aid measures, general advice, eye contact, skin contact, inhalation, ingestion, most important symptoms and effects, and note to physicians. Down here you'll have the firefighting measures, and as you can see, they don't really have a whole lot because this isn't very flammable. So most likely the fire that's going to have this involved in it is something else that's on fire that happens to be burning the cadmium. So this is not very flammable, but it can burn because something else is on fire. They don't really have a whole lot as far as fighting the fire. What they do have is highly toxic fumes, personal protective equipment and precautions for firefighters. Down here it says wear scuba if there is a fire that has cadmium inside of it. Next we have accidental release measures, adequate ventilation, use PPE, avoid dust, keep people away from and upwind of spill or the leak. These are the basic accidental release measures. Environmental precautions, no flushing down the sewer. And of course you'll have the cleanup methods. That is also included in this section. But cadmium's not that bad for cleaning up. Things like gasoline, diesel fuels, those kind of flammable liquids, they'll have a much bigger section here. And now we have handling and storage. And one of my favorite issues that a lot of SDSs have is wear personal protective equipment. What PPE? You cannot just say wear PPE. You got to tell me what. But here we go, an SDS that tells me wear PPE. Now, it also says don't get in the eyes, on skin, or in clothing. That's all good. Avoid the dust formation. Good to go. Use only under a chemical fume hood. Do not breathe the vapors or dust. Do not ingest. Keep containers tightly closed in a dry, cool, well-ventilated place. Store under an inert atmosphere. Now, this is one of those situations where if you'll look at all the chemicals that are in, I don't know, your Connex. A lot of us have got Connexes or outdoor warehouses. Look at all the chemicals in there. Take the SDSs. Look what it says here for storage. A cool, dry, and well-ventilated place. Do you think that your Connex stays cool in the middle of the summer? Think about it. Now we get into exposure controls and personal protection. Down here you're going to see the ceiling. Now these are all TWAs, which is a time weight average. This is all how much you can be exposed to over X amount of time. Give it the competent person for your company, for hazardous materials, for your job site, and they can explain this to you in much greater detail. Overall, it's how many parts per million you can breathe in or be exposed to over an X amount of time. Moving on down, we have our engineering measures that can help control things, a chemical fume hood. Moving down, our personal protective equipment. This is what I wish they would have set up there in handling and storage, but at least we have it down here in PPE. Appropriate eyeglasses, chemical safety glasses, long sleeve clothing, respirator, do not eat, drink, smoke, so on and so forth. This is where you're going to have a lot of your measures for handling this chemical. Next, we have the physical and chemical properties. What does it look like? What does it smell like? When does it melt? Boiling point, flash point, flammability, vapor pressure, solubility. This is all of your generic information for this chemical. Next, we get into stability and reactivity. Reactive hazard? No known. This would be one of those things where theoretically, if you, I don't know, there were two chemicals that if you mix them together, it creates mustard gas. This would be where it says, keep this away from this other chemical because they react with each other. Stability. Stable under recommended storage conditions. Conditions to avoid. Incompatible products. Excessive heat. Incompatible materials, oxidizing agents, acids, sulfur oxides, so on and so forth. What all does this thing react to? This next section, toxicology information, this is, as far as I know, the only people who would ever really use this is coroners whenever they're actually trying to figure out what are all the chemicals you've got in your body. And this, all of this information gives them a good map for how to identify cadmium in the body. But if we keep reading into toxicology, you're also going to look down here, delayed and immediate effects as well as chronic effects from short and long-term exposure, meaning it's acute and chronic. Keep looking on page 6. Mutinogenic effects. Yes, this is how you get the three-eyed fish in the Simpsons power plant lake. Except this isn't talking about a cartoon or even the environment. This is talking about you in your body. It could have irreversible effects inside of your body. Reproductive effects, possible risk of impaired fertility, it may cause harm to unborn children. Developmental effects, respiratory system, kidney and blood issues, kidney disorders. And then, of course, my favorite thing, the toxicology properties have not been fully investigated, meaning we don't truly know, in the end, every single thing that could possibly happen. But this all is enough for me to go, okay, this is bad. Then we look down here in our eco information, and of course we all know our pictogram. And this can cause harm to the environment, including making fish float out of the lake. Parts per million, it can definitely contaminate freshwater fish. And here's all kinds of little parts per million information down here. You keep going on page 7, you got persistence and degradability, bioaccumulation and accumulation. Depending on the spill you have, these could really play a major factor. Otherwise, they're not that important unless you have a spill. Disposal considerations. This is real simple. How do you get rid of it? Can you just throw it in the trash can? Or do you have to do something fancy with it? Next, we have transportation information. This is a 1926 focus class. We are not focusing on dot or dash training. So transporting information does not apply here. I'm not training anybody with this video to transport anything. Regulatory information. This is where we get into who regulates what and how they have any kind of a say-so and what section falls under what and so on and so forth. Who regulates it? Again, this is international. We're not looking at this because I am not training anybody with this video to transport it or to move it or to have to deal with anything other than 1926 construction standards. Continuing in the regulations, if you look down here, you'll see U.S. federal regulations, and this is where things may apply. We have our hazard categories. We have our Clean Water Act, our Clean Air Act, any OSHA standards that may or may not apply, California Prop 65, U.S. States Right to Know. This is where, if this product is known to be regulated by some agency, whether it's a state OSHA or it's regular OSHA or it's some other government entity's regulation, it should be listed here. Not always, but it should be listed here. And finally, we have our last page. This is our generic disclaimer information, revision date. This is, for them, this will be the closing. This is safety data sheets. And next we have global harmonization. These are the GHS pictograms. If you see this image, it is for explosive or reactivity hazard. This image for fire hazard, oxidation hazard, gas cylinders under pressure, corrosive hazards, toxicity with short exposure to small amounts, health hazard in general, serious health effects or damage to the ozone layer, and as we already discussed once, environmental hazard. This is a generic symbol down here of biological hazards. That's why you'll see that in hospitals a lot too. This is your global harmonization pictograms, GHS pictograms. Next! Almost done. Let's get into some regulations. 1910-1200 Bravo 3 II. Employers shall maintain any safety data sheets that are received with incoming shipments of hazardous chemicals and ensure that they are readily accessible during each work shift to employees when they're in their work areas. Meaning they have to have access to all their data sheets of every chemical they're working with at all times while they're working in their areas. 1910-1200 Echo 4, the employer shall make the written hazard communication program available upon request to employees, their designated reps, the assistant secretary, and the director in accordance with the requirements of 29 CFR 1910-1020 Echo. 1910-1200 F6 Workplace Labeling. Except as provided in paragraphs F7 and F8 of this section, the employer shall ensure that each container of hazardous chemicals in the workplace is labeled, tagged, or marked with either F8. The employer is not required to label portable containers into which hazardous chemicals are transferred from labeled containers, and look at the word here, and which are intended only for immediate use of the employee who performed the transfer. So let's say for whatever reason we have this PVC glue and we want to pour it into another container so that way two people can use it at the same time. Now let's say we want to pour it into this bottle right here. The first problem is this is labeled as Gatorade, which means you cannot pour PVC glue into a Gatorade bottle because it's labeled as Gatorade. So we strip off that label and now we can use it as a temporary container. But again, look at the regulation. It has to be by the person that's using it and only for short term, which means your supervisor can't do the pouring and then the employee use it. It has to be the person using it and short immediate time, which means doing this and then using that same bottle for like 5 or 6 days, that is not immediate. This is an only tiny small exception for immediate use. 1910-1200 F9, the employer shall not remove or deface existing labels on incoming containers of hazardous chemicals unless the container is immediately marked with the required information. 1910-1200 F10, the employer shall ensure that workplace labels or other forms of warning are legible in English and prominently displayed on the container or readily available in the work area throughout each work shift. Employers having employees who speak other languages may add the information in their language to the material presented, as long as the information is presented in English as well. 1910-1200 Gulf 8, the employer shall maintain in the workplace copies of the required safety data sheets for each hazardous chemical and shall ensure that they are readily accessible during each work shift to employees when they are in work areas. Electronic access and other alternatives to maintaining paper copies of the safety data sheets are permitted as long as no barriers to immediate employee access in each workplace are created by such options. Which means you cannot have like this one computer that everyone has to go to for their SDSs, but nobody has the password. Or only the supervisor has the password. Or it takes 35 minutes for the employee to get to that computer. Makes sense? If you're going to go electronic, the employees have to be able to get to it like that. 1910-1200 Gulf 9, where employees must travel between workplaces during a work shift, like their work is carried out at more than one geographical location, the material safety data sheets may be kept at the primary workplace facility. In this situation, the employer shall ensure that employees can immediately obtain the required information in an emergency. 1926-95A, application. Protective equipment including PPE for eyes, face, head, and extremities, protective clothing, respiratory devices, and protective shields and barriers shall be provided, used, and maintained in a sanitary and reliable condition wherever it is necessary by reason of hazards of processes or environment, chemical hazards, radiological hazards, or mechanical irritants encountered in a manner capable of causing injury or impairment in the function of any part of the body through absorption, inhalation, or physical contact. 1926-95 Delta 1, except as provided by paragraph D2 and D6 of this section, the protective equipment, including personal protective equipment used to comply with this part, shall be provided by the employer at no cost to the employees. So, Hazcom wrapped up in a nutshell? Very simple. Supervisor, you're responsible for all the hazardous chemicals that your company has brought onto the job site that your employees are going to be dealing with. Make sure the labels are good to go. Make sure you check all the SDSs. Every single chemical you need to have an SDS for. Make sure you read the SDS. Make sure you store the chemical as per the SDS and you dispose of the chemical as per the SDS. Make sure you have the PPE available to handle the chemical and that is accessible to the employee that you expect to handle the chemical. As well, SDSs need to be available to all the employees and supervisor. It's your job to ensure that the employees are familiar with the SDSs, where to get them, and the PPE, as well as maintaining and cleaning the PPE, and the PPE is at no cost to the employee. I hope this video finds you well. I hope that you took something out of this video, and I'll see you in the next one.